Hi, this is Enrico from Jarenga. So we had a request to show a method how you can trigger jobs or tasks or programs in the AUBO robot from a PC-based system. So today I'm gonna show you how to connect from the client to the robot. The client in this case will be my notebook, and then trigger different tasks, different jobs on the AUBO. Okay, let's go through a couple of things first. So we start today. You see on my screen we are on the robot in simulation mode. So I'm not gonna move the actual robot. I'm just gonna do the simulation. Everything else is gonna function exactly the same. Only we have no physical movement. Okay. Then we go under program, and you see I already opened the script editor. And I made one script which is printing hello world. The first question is, where does it print it to? So any prints are going to go to the system info to the log file. So it's going to be along this information here. And then yeah, let's go move forward and have a look. So we are programming here in a script editor in Lua. So if you are not familiar with that, you may want to check the syntax, because it has a couple of special things, especially when you're used to other program language like Python or C++ or C#, or just C or Visual Basic, for example. There are quite a couple of things which are different and you need to know, otherwise you spend quite some time on that topic. Okay. Let's go to the project. You see here I use an empty project test at the moment. We want to first run the script once and execute it. It should be only print hello world. So we go under project. We add a condition, which has to be an advanced condition. And then, we go on a script. We mark the script, and then we have to select script file, which we have here under the script section. So at the moment this file is saved already, so I don't have to save it again. Going to the condition, script file, and now I can select the script print test. Confirm. Okay, it's in the project. Save the project, and then let's execute it. Okay, since we don't have a loop, it's only executed once. We move over to system info, and we would expect hello world, but we don't see it at the end. The problem is here that there's a lot of info messages at the beginning and at the end for the program execution. So that's why we have to scroll up quite a bit beside all the other messages we had. And then here we see that we actually printed it to the system info. So again, the reason is that when the program is shutting down, there's a lot of information which is entered there as well, so it can be a little bit confusing sometimes. So one way to avoid that is to print it and not finish the program. So for example, if we go in and we add a wait time, make this thing to 5 seconds so we don't have to wait here forever. Okay, we just need enough time to go to the system info to see it. So okay, wait 5 seconds, confirm, save the project. Okay, and then execute it. Right now it's in the waiting period. Change to system info. We see here there's hello world, and now we see all the messages from the closing program. Okay. Another method how you can do that, and which leads us closer to the target of the TCP communication today, is that we set the main program into an infinite loop. This one we can remove as well. We start fresh here. We make a loop, so we don't want the main program to end always. Okay, and then we just add a wait time of a second in there. Okay, done. The reason why we set the wait time of 1 second is the program is not doing anything. There is nothing delaying the execution at all, so it means it would run with maximum speed and potentially interfere with any other programs in the background, because it takes a high CPU load. So whenever you have any loops, make sure there's any form of wait time in to slow it down, otherwise it's really going to cause you more problems. Okay, that's safest project. Okay, so right now we're not doing anything, but we wanted to see the hello world message a little bit clearer. So what we can do is we can add to the program what is called a thread. So a thread is essentially a smaller program or a program-like process which is running in parallel to the main program. So they run independent from each other. So when we mark the thread, we confirm that one. So for threads, there is the same, a high risk that you always want to loop within the thread and do watch something. For example, for our communication, we want to watch for incoming messages. So there is a loop, and we have a template already showing you that you should have a wait time in there to not interrupt the main program with your loop taking too much CPU time and running too fast. Okay, here we have a loop. Always, it waits 1 second, and then we can do what we like here. So we go for advanced script and add our hello world script again, which we saved under print test. Okay, save a project. Okay, and then start. Let's go to system info, and we see, because the program doesn't end, it keeps writing our hello world every second through the loop of a thread, and the main program is just running idle on that one. Okay, that's nice. That's a little bit cleaner. Good. Okay. So obviously the printing test is only to give you like a first step on how the scripts work and that you can test the basic functionality. We want to do a little bit more with the scripts. So I'll close the print test one, and you see I prepared a script called TCP server for this application. What we want to do is we want to connect from the notebook to the robot. So the robot will be the server, the notebook will be the client. And then we want to send tasks in the form of numbers to the robot, and we wanted to execute these. Okay, we are scripting here. For you to make it easier, you can see it here later on a website, or maybe by the time you watch this video it's already on. We will have scripts available for download and more information on the blog post. There is a script manual available for AUBO. I'm not sure if I'm allowed to share it. If we are allowed to share it, we will put it on our website then as well. For now, with the parts we are showing here, it should allow you to move forward. Okay, what are we doing? Let's go through the script one by one. So first of all, red parts are comments. Then the second thing is here we are doing a variable configuration. So whenever we use something more than once, it makes sense to configure a variable for it. Here, in this case, we configure the client IP address, which is the IP address from my notebook. So essentially, AUBO will check if the client IP, the one connecting, is the one we configured here, and then only accept the communication. However, anybody could use that IP address and connect to the AUBO and send tasks. So you only want to do that in a secure internet environment, not in an internet environment or anything which is not protected by other measures like firewalls and routing systems in place. So for testing and basic setup, it's fine. In a machine network where you are in control or who can do what in there, that's also fine. But don't use it in open environments especially. Okay, so second thing we need for the connection and the communication is we have to tell the AUBO on which port it's supposed to listen. There is a couple of standard ports where the operating system is using, which you shouldn't block. There's a couple of ports the AUBO PE software is using, which you shouldn't block. So my recommendation is use between 8001 and 8010, which should be more than enough for you for your testing, so then there's no risk that you interfere with anything else in the system. Good. The next command is the server listen command. So it essentially just starts the server mode on that port, waiting for the client with the IP address to connect. Then we have a while loop. So we will not use the loop function in the thread because we would like to stay fully in control on how much time the thread is actually using running through. So we will delete the loop from the template, and we will just use the script later on. That's why we have to make sure that we don't execute only once. That's why we have the first while loop. Then the second while loop, you can see here in the comment, it's which I made for you, is when a client is connected already. This will be executed. If you just start your server, and which the script basically does, is there is no client connected yet, so it will jump over down here to the second one, which is executing while there is no client connected. Okay, here I mentioned earlier the syntax. This is the not true, yeah, so in this case would be false. You have to be careful that you are not making the mistakes from a different programming language, expecting it to behave the same. This is Lua, this is how you have to program it here. Okay, what are we doing on the function side? We are checking whether the flag is connected is true, is not true. Okay, which means we expect a client IP, which we defined earlier, so we expect a connection from that client under that IP, which is not there yet. That means we are looping then, which the sleep 1 is a wait time of 1 second. We keep looping as long as nobody is connected to us. There's no reason to do anything. So we just wait and wait and wait. At the moment where a client connects to the port correctly, we will jump out of this loop, end up in the main loop, which starts here, and then executes this part of the function. Here we see that the is connected is actually true, which means, okay, yeah, we have finally a client connected. As long as the client is connected, keep running through this loop, otherwise go back to the waiting loop. Okay, good. What are we doing here? The overall plan is as follows. We have the thread and we have the main program. Let's go back one step. So the main program at the end is going to hold the task we want to do and execute, and the thread is the one doing a control of the main program, because the thread is the one which gets the information from the client. Okay, to be able to exchange information between the thread and the main program, we use global variables in the system. These are variables which can be accessed by the main program as well as the thread. How do we do that? We are going on the left side under config. Then we have variable config, and you see I already configured a variable vi job, which is an integer variable where it's a global hold false and has a value of 0. Okay, what does it mean? First of all, the variable job is only the name part. The I stands for an integer variable, which means it has to be a number. And then the value is the initializing value. At the moment you start the program, it will be set to 0. And the global hold is every time when you are starting your program, your variable will be initialized to 0 unless you put a global hold in. It basically tells the variable to store the number from last time. So if you want to carry over some information from the last program execution to the next program execution, the global variable is what you're needing with the global hold. Right now, we want, whenever we start our program, to be the system initialized to 0. That's why we are not using a global hold. Okay, let's jump back into the script. Good. So what are we doing here? So again, this is the client is connected already. So what we want to do is we want to see if we received any data from the client, because that's the only way how we can execute anything. So we create a variable receive in the loop. Then we reset it here. So if in the first loop it gets created, in the second loop it will just be reset to the initial value of nothing. And we are dealing with strings here in the communication. So that's the way how you define that. Then we have a while loop. Yeah, so this one loops as long as our variable is empty. So we set it to empty, and as long as this one is empty, it will keep looping. Okay, why are we doing that? Because we want to check if we got something from the client, if it sent us something, then we will add it in the receive, and at that moment we will break out of this loop and actually do the execution after. As long as we didn't get anything, receive will be nothing, and that means it will just wait 200 milliseconds and then check again. So it will just wait and check and check and check. Did we get something? Okay, now we jump out. What's the first thing we do? We are printing the information, the client IP, send, and whatever we received in a variable into our system info. This is just for debugging purposes, and you can also comment some parts out in the rest of a script if you want to see if you make it until that spot and so on. Okay, this is solely purpose for information. Then the next part, what we're doing here is we are sending string data to the client and receive. So what we're doing is, again, to test the communication easily, whatever we received from the client, we are just sending back to the client. So that makes it easy to test if your communication actually works. Then we have this while loop, which we are not going to talk about right now. I will come to that a little bit later when we look at the program execution. And then the same goes for this command, where we are just sending a 0 back to the client. And then we come to the actual most important part is, if we received something from the client, this is basically here held in this variable receive. Yeah, so here we received it from the underlying command. It is in a variable still written. Whatever we received there, we transform into a number, and then we set it on the global variable vi job. Yeah. So again, we are only expecting numbers here. If we are sending any letters or anything else on this string, this is going to fail. The program is going to stop and it's not going to work. Yeah. We only have global variables from type integer, double, and pose, and Boolean actually. We don't have string variables, so we deal with numbers here on this stage. Okay, good. So once we set that, we are setting the global variable vi job. And that should be it. Okay, let's jump into testing that. We're gonna select, we have our program, which we just did. We said we want to take the loop out because we are controlling it in our script. And we're gonna add the script from advanced, mark it, script file, and then the TCP server confirm. Okay. Keep in mind the global variable we set before, otherwise we're going to have issues and we're going to get an error on the TCP server script here as well. Okay, let's project, save it. Okay. So right now program main loop is running, the TCP script, let's check again, because of this while loop is also running as long as the program is running. So this is our definition for wait for the connection from the client with the IP address 169 at the end. Then check if you received something. If you received some data, which we expect to be a number, then write it in the global variable vi job. Okay, so this is what the thread does. Then later we will look into the program is going to look at the same variable, and if it's not 0, it's supposed to execute something. Okay, let's test the communication first, because we said whatever we're receiving, we are sending back, and then we send another 0 after. So we can execute the program, start. And now, how do we connect? Okay, let me make this screen a little bit smaller for the robot. So this is ready to go. Now we use a small application which is called socket test. So this is how it looks like. So this is running on my notebook right now. Let's make it a little bit bigger. Yeah, so this is how it looks like executing, and where you can find it is it's an open source application you can download from SourceForge. It's a really nice tool for testing TCP client and server connection, so I recommend that. If you have any other tool you prefer, go ahead. I'm going to show in this version how we use socket test. Okay, let me put the browser away. And then socket test. Okay, so what do we have here in socket test? I'll make it a little bit smaller for a second. We see here on the left screen, my robot is under the IP address 10.10.1.100, and the robot is the server. In socket test, we can define whether we are using a client or as a server. Okay, so the robot is the server. Let me just redo it again, because I think I moved on the wrong screen. Here, when you see in the left in the robot window, on top of a bar there is the IP address the robot is using in server mode, and on the right side is the client on a notebook. That's why we are running in client mode, and it needs to connect to the robot under that IP address. And remember, we defined port 8001 for the connection on the robot. Okay, so if our script is running right now on the robot side, our socket test is ready to go. Let's try to connect. Okay. I can take a moment with socket test because it checks some items in the background. Okay, so now we have a connection with the robot. Let's check in the system info on the robot. we see here that the server was started, and we see here that we just connected with the IP address 69 on the port 8001. Okay, so the connection is established, that works, which is great. And then the system is running. We wanted to send a number like 1 or 2, so I'm going back to socket test in the message field, send a 1. And then here in socket test, the part written with S is what we send, and the lines or the rows under it is what we received back. So we received a 1 and a 0 back, which is good. Let's try the same with 2. One thing for socket test, you need to know if it doesn't get an end of line message in the message back, it will just keep writing in the same line. So here the 0S2 means we received 0 and then we send 2 again. Then we received 2, but this time we didn't receive a 0, where I will explain in a bit when we look at the program execution why it is the case. Okay, so communication works so far. Let's see, how do we know whether we received anything? Under system info, we earlier in the script we wrote into the system info that the client under which IP address sent us 1. Sent us what? It sent us a 1 first and it sent us the 2 second. So this works. The only thing to confirm last is, did it actually write it in a global variable? So if we go under programming, you see here when we executed that, since we are in a simulator, we automatically go to the state screen. We can check under variable state. We can see right now, okay, our variable vi job got the number 1, but it did not get number 2 from before. This is what I intended it to do, so it's actually working fine. We'll have a look in a moment why it did not use the second command. Okay, I will disconnect socket test now. Just clear the screen so there is no confusion and stop the robot program. Okay, now I'm loading a project which I prepared, so you don't have to wait too long. This is a TCP server command, load. It's the same thing for the thread. It's just executing exactly the same script, only that I already added some action under the main program. Okay, let's have a look at the main program here. So we have a move with a waypoint, which is my start waypoint. And then we have a loop with a switch case condition, which we go through now step by step. So first, I tend to do an independent move in the program at the beginning, because we need to define where the robot is supposed to start, and we manually have to drive it to this position. Let's look at this one. So we use an I10 in this case, and this is the start position already for the robot. Okay, then the main program, remember, doesn't loop by itself. So my move will be executed at the beginning, and then I only have the main loop in the program. So that is what's actually executed constantly, and not the move on the top. Here I'm saying loop always. Okay, fine. What is it doing exactly? So it goes into a switch case instruction, and when it's done, it will wait a defined time, and then it will loop again, do a switch, and then wait, and then loop and switch. Okay, the thread, remember, is running in parallel, checking for the communication. What is a switch case? So a switch case is a method when you have a variable which can a variable that has different values, and you want to not use an if else check. You can use the switch case, which makes it a lot much easier and much more stable and nicer to use. It is used in most other programming languages as well, so people who program should be familiar with it, and people who are not that experienced in programming. Here's the switch condition at the beginning. It is not a condition like a check. It wants to know what to look at, in our case the variable vi job. Then you can add cases, and here we say case 1 is the name, the alias I gave it, and here's the condition. So I said 1. So what it does is it checks if the variable vi job is 1, then do whatever is under case 1, which is here a set and a move. If the vi job is equal to 2, then do that one. If it is anything else, then execute default, and then you are done, and then wait time and do again. Yeah, so essentially I have a case 1 and 2, which is my job 1 and 2, which I want to send. And if I don't send anything, or if the system is idling, I want it to execute whatever is in default. Okay, What is default? Let's start with that. Default for me is here another move which brings us back to the start position. So I'm saying whenever I don't know the number I got sent, like 3, 4, 5, 6, 7, 8, or when I have a 0, which I use in my case to initialize the system, then it will execute default and it will go to the waypoint start. If it is already in the waypoint start, it will not move anywhere just because it's basically a successful command and will just move on the next case. Okay, then we have a case 1, which is my first job move, and a case 2. So what I'm doing here is I created a waypoint A, and in case 2 I created a waypoint B. Okay, when we look at the start position, this is the same here, start the program. If we send the job 1 and I tell it I wanted to move to waypoint 1, it's going to move down. If we are at the start position and I tell a waypoint B, it's going to move to that position. So A means down, 1 is equal to A is down, and send number 2 is my waypoint B, which is on the right side. If we don't have any of these commands, it's supposed to go back to the start position. Okay. So let's have a look then how it's running. We will start on the robot. Okay. Right now you see that we are already in the start position, which is great. Now it goes in a loop. Right now the global variable is 0 because this is what I initialized it with when we started the program. So it means check. If it's 0, it's not 1, it's not 2, so it's default. Go back to a start waypoint. It's already there, finished. Loop again, loop again, loop again. So essentially it's just waiting until it gets a different command than going to your start point. The thread is running, but we are not connected with the client yet. So let's connect with the client. Takes a moment. Okay, we are connected now, and now I'm going to send number 1, which is job 1, which should bring it to waypoint A. So send. Okay, it received. We see it goes slowly down to waypoint A, which I programmed, but now it's going back to the start waypoint. Why is that? Okay, the reason is that I have a set command in the case. Let me stop it for a moment. I have a set command before the move. So what I did there is switch checks what number do we have under VI job. Then if it's 1, it's going to go in this case and it will execute whatever is here. So I'm letting the system know that I reset the variable VI job to 0 because I'm executing my job, and when it's done, it can get the next round. Then this one is done and didn't get any other command in between. The variable is 0, it's going to check, goes to default and moves back to the start waypoint. Yeah, the same I do in case 2. If I start this condition and execute this part here, then I'm also resetting the variable. That's why if it doesn't get another command, it will automatically go back to the start position. Okay, I run this very slow. Let's look at the same thing a little bit faster. So running this one again, going over to socket test, clearing it and reconnecting. Yeah, I restarted the program, so I have to do a new connection from the client side. Okay, now let's send 1. Okay, robot is moving there. Okay, remember job number 2 was on the right side. Let's send it over. Okay, good. Now I will send 1 again. Okay, works. 2 again. Okay, works. Okay, now I'm going to do a short sequence 1 and 2. Okay, so now we got a different move. Okay, so why is that? So what happened here right now is, let me stop the, I can keep the program on so you can see the simulation. So what happened is, we sent the first command, number 1, which says go down, this is possible to see on the screen, go down to the lower position here on the green tip. Once we start moving, we reset the global variable. And when we move down, and while we reset the global variable, we already set the command number 2. So which means when it arrived here, it did not try to make a move back with 0 to the start position. That's why it executed moving to position B because we got 1 and 2 as a sequence. So before, when we went slow, we essentially did in the loops 1, 0, 2, 0. That's why it was moving down, up, and then right back. Okay, let's show you something in a script which I skipped over earlier. Stop the robots. Let's look at the script. So here in the script, what I did here is, again, here we receive something from the client. In this case, in our case, we received number 1. Then it skips this loop, sends it in our info screen. Then it returns 1. So when we look here over on the side, let me clear the screen for now, disconnect. I'll execute it one more time so we have it clean on the left side. Start, connect with socket test. Then we send a 1. Okay, so we see here right now on socket test we sent a 1, we got the 1 back, and we got a 0 back, and now we're going to send a 2. And then we got a 2 and we got a 0 back. Okay, let's go to the script. Okay, script. So we received 1, we sent back 1, and now here, this is the loop which I skipped earlier with you, is here I'm checking when the global variable job is not equal to 0, then you loop in a cycle of 200 milliseconds. So what I did here is when we received the first command 1, we want to execute that one. This only works if the variable at the moment is 0. Then it will skip this loop, and then it will send a 0 to the client, and then it will set the global variable. So why did I do that? So the background is we could theoretically send a short sequence of commands 1, 2, 1, 2, 1, 2, and accidentally skip one of the commands if we would always overwrite the global variable directly. So if a robot would move very, very slow, like I've shown you in the simulation, we would theoretically overwrite and skip jobs, which we don't want, which is also dangerous in application. So what we said is only, go back to this one, only when the variable is 0, then you can send 0 back to the client, and then you can write the global variable. Let's look at the program. Remember here in the case, the first thing I did after I got the global variable, which is not 0, in this case 1, I set the global variable to 0 because I'm already executing this job under 1. Yeah, so right now the communication can write the next task into the variable. So once I'm done with executing my case, I'm looping again. And if we wrote something new, like we did 2, I will directly execute 2. If we didn't write anything in there, it is still reset to 0 from this command, so I will go back to the start position of the robot. Yeah, it's very important to always control where your robot goes so you don't have any unintended movements along the way. Okay, let's look at the script again. So only write the global variable when it is 0 is what we do use this while loop for, and moving on and send it here. Okay. Then another thing I did is I sent a 0 back. So let's look on the right side on a socket test. So the client sent a 1 to AUBO. AUBO received a 1. AUBO sent back whatever it received. So this now basically with the client, if you write your own software there, you at least know that your command is well received. Yeah, as a confirmation, a very basic confirmation. Yeah, there's a million other ways and more stable ways to do it, but it's a very basic confirmation at, yes, okay, my command was actually received and I got it back. Okay, then I'm sending a 0. So the 0 essentially is only written when the global variable in the program is reset to 0. That means that the robot is executing something and is ready for taking this command. So again, slowly, the client sent 1. As a client, I know at the moment where I got 1 back, the AUBO received my request, but it is not handling it yet because it cannot write it in the global variable unless I got the 0 back. Yeah, and then the same is for we send job number 2, and then the 0 is just a confirmation. Right now is the moment where I'm writing your request into the global variable. Yeah, it's a little bit more of a handshake that you know okay, your command is received, but is it actually in the queue to be executed? Yeah. In a normal application, you would add a lot more states in between because you need to know when you can send commands, when do you potentially have to repeat commands, and so on. Okay, good. That's the basic handshake. There may be some questions for it. Feel free to contact us on that one. I'll run through the program one more time. Where let's start disconnect the notebook first. That's on a robot. I will reduce the speed now very, very low, and I'll guide you through the process again. Let's do like 7% or so. Okay, I'll connect to the socket test to the AUBO. Yeah, I'm now sending the number 1. I get it back right away, and I get the 0 because the 1 was written in a global variable and the robot is executing it. The robot moves to the lowest point. At that moment, the robot has no new job yet the global variable is 0, so the default part in the program is running, which brings it back to the start point. Okay, if I send 2, receive 2, and then I get the 0, so I know it's in progress. Okay. If I would now send the command before it finished the move, before it reached the position B, or the waypoint B, or the same for A, if it's not done yet and I already write a new command, it will not go back to the start position with the execution of 0, it will go to the next position. Okay, I will do this now. I will send 1, and before we reach the bottom point, I will directly send 2 after. Okay, send 1, 2. Okay, right now 2 is already in the queue, and it will move to the waypoint B instead of back to the start point. Yeah, and then it will reset to 0, and now it will move back to the start position. Okay, so it is an option for controlling between the master and the client, or in this case the server and the client, so that the client knows when is my task actually executed, when can I send a new one. And for you, it's an advice you really need to keep in mind what your program is actually doing, that you don't have any unintended moves, because originally we didn't say we actually want to move from A to B. We said we want to move from start to A and from start to B. So you have to be very careful on the program that you make sure you don't have accidental moves. Okay, that's for this video. If you have any questions, let us know.